So folks, in the last pre-work, we talked about the three different forms of a line that we're interested in. And these first two are we want to talk about as we go to graph these lines. So let's go ahead and put this all into practice here. Number 3 says we want to plot y equals negative 2/3 x plus 2 using the slope-intercept form of the line. So how's this going to work? Well, previously we said that the slope-intercept form of a line looks like this. It's the y equals mx plus b form, where m is the slope, which we commonly think of as rise over run, and we'll have a review of slopes specifically in another pre-work, but I just want to, you've probably seen this before. And the b value, b is the y value of the y-intercept. Put another way, the y-intercept, remember that's the point, remember y-intercept is a point where a graph crosses the y-axis. The y-intercept is the ordered pair 0, b. So in our line, by inspection, we know that the slope is equal to negative 2/3 and that the y-intercept would be the ordered pair 0, 2. So what I'm going to do now is I'm going to go ahead and plot the y-intercept. So we're going to go up 1, 2 units, and now I'm going to go ahead and plot that y-intercept. That's the ordered pair 0, 2. And now what I'm going to do is I'm going to go ahead and use the slope to find an additional point on this line. Let me put some more tick marks on here. So what I'd like to do is remember that if we want to graph a line, it's enough to find 2 points. And I know 1 point just from by inspecting this form of the line. Right off the bat, I know that 0b is a point on this line. Now what I'm going to do is I'm going to use the slope as a recipe to find an additional point on this line. We know that this ratio of -2/3 has to hold for any collection of points on this line. Specifically, if I were to start at this line and I were to go over 1, 2, 3 units for their run value, and then I were to rise -2, that's the same as going down 2 units, I would be at another point on this line, and I could go ahead and plot that point right there. I could continue with that. There's something that says I have to stop there. If I go to the right 1, 2, 3 units, and then down 1, 2 units, I'm again at another point on this line. So what I can do now that I have actually more points than I need, 3 points on this line, I can go ahead and extend this line through these points that I've already sketched. So I'm going to sketch it once by hand, folks, but then you're going to have to bear with me because it's not going to look good, and I'll just come back and fill it in with the program. So here you can see, folks, I've gone ahead and sketched the line that passes through these 3 points. I did so using the slope-intercept form of the line, where I determined m, in our case, was -2/3, and that the y-intercept was the ordered pair 0, 2. And then again, I used the slope as a recipe to find an additional point on the graph. Okay, I want to point out one other thing here. I chose to go to the right 3 units and down 2. I could have also, from this point, opted to go to the left 1, 2, 3 units. If I were to do so, I would have gone up 1, 2 units, and I would have again been at some other point on this line. If you wish, you could label the coordinates of those points that you plotted, but that's how we sketch a graph when it's in slope-intercept form. Okay, so let's scroll down here. Notice in this problem, in part number 4 here, I'm asking you to again graph this same line. We want to go ahead and again graph it. But in this case, we're going to use the standard form of a line. Now, this is not the most efficient way to graph this line, but I want to convince you that it doesn't matter which form my line's originally given in. I can always try to use both methods. So what I'd like to do here is I'd like to move this into standard form. Remember that standard form looks like ax plus by equals c. I noticed 2 things. First of all the x's and y's are collected to one side, so let's go ahead and do that. If I were to add this -2/3 over, I get 2/3 x plus y is equal to 2. And then the next thing to notice, well, I guess you don't have to, but I don't like this to have fractions in it. So I'm going to go ahead and multiply both sides of this equation by the number 3 to eliminate those fractions. And there we go. And so if I were to do so, I end up with 2x plus 3y is equal to 6. Okay, now I have this in the general form, ax plus by equals c, and I eliminated fractions. Why do I like general form? I like general form, I like standard form. I said that incorrectly, folks. I like standard form because it's easy to identify the y-intercepts, the x and y-intercepts. So if I want to find the x-intercept, let's remind ourselves of something. This is my x-axis here. Please don't write this down because I'm going to erase it. If I were to select any point along the x-axis, these could all have various, maybe this is x equals 3, comma something, maybe this is x equals 2.5, comma something, maybe that's the origin, which would be 0, comma something. This would be maybe -1, comma something. What do I notice at all points along the x-axis? They all have a y-coordinate of 0. Okay? So let's use that fact. If I go to find the x-intercept of this graph, what I'm going to do is I'm going to say, well, we know if we're on the x-axis, the y-coordinate has to be 0. So we let y equal 0 for precisely the reason that we just explored. So look at how easy it is to solve this equation for 2x plus 3y equals 6. So let's see here. We'd have 2x plus, and then actually I don't usually write this step. I usually just zero that expression out, equals 6. And then what I like to do is this, I call it the cover-up technique. And so in the video what I'll do is I'll put a box around here to cover that up, and then I'll solve that very simple equation in my head for x. So doing so, we could just solve that in our head to give us x is equal to 3. Likewise, if we want to find the y-intercept, let me finish one thing up. We found the x-coordinate of the x-intercept. So what is our x-intercept? It's the ordered pair 3, 0, where I always knew that the y-coordinate was going to be 0, and then I found the x-coordinate to be 3 through that cover-up technique. Okay, so if we want to find the y-intercept, well, anywhere, don't write this down, folks, anywhere along the y-axis, what do we realize? Anywhere along the y-axis, well, we might have different y-coordinates. We're not sure what they are. The x-coordinate is 0 anywhere along the y-axis. And so to find the y-intercept, we're going to let x equal 0 for precisely the reason that we just saw. So then we'd have 2 times 0 plus 3y equals 6. And then what I'm going to do is in the video I'll put a box around here and cover that up, and then I'll solve that result in my head. So doing so, solving that resulting equation in my head, I get that y is equal to 2. So what does that mean? That means that we have the ordered pair 0, 2 is the y-intercept. Again, we knew that the x-coordinate was going to be 0 because we were looking for a y-intercept. And always a y-intercept has an x-coordinate of 0. So we knew that was going to be the case. Then we use this cover-up technique to figure out that y equals 2 is the y-coordinate of the y-intercept. By the way, we also already knew that when we were way back here in our y equals mx plus b form. We already knew that the y-coordinate would be 2. But I'm illustrating you how we use the standard form here. Okay, so now that I have these two, intercepts, we can go ahead and plot them. So here was our x-intercept, 1, 2, 3, and there's our x-intercept. I'll put it in green here. Here's our x-intercept at the ordered pair 3, 0. Now let's go ahead and plot our y-intercept. So pause the video, plot the y-intercept. So hopefully what you did was you went ahead and used your tick marks. You counted up 1, 2, and then we went ahead and plotted the y intercept, which is the ordered pair 2, 0. Now that we have these 2 points, I'm going to draw the line that connects them. So I'll just cheat and let the computer do it, help me out. So here you can see I've graphed this second line. It actually looks identical to the line we graphed before, and that better be true because we're using the same line. And sure enough, these two graphs look identical. And we did this one using the standard form of the line, where instead of plotting a point and then using the slope, we went ahead and plotted the two y-intercepts. Okay, so let's do the same thing here. Let's look at number 5. We're asked to plot the equation 2x minus 3y equals 12. And I'll argue that most students, if I were to give them this problem and tell them to plot 2x minus 3y equals 12, they would do this particular method. What they would do is they would go ahead and put this into y equals mx plus b form. And there's nothing wrong with doing that, provided that you learn these other methods as well. So now to get y isolated, I'm going to divide both sides of the equation by y equals negative 3. And simplifying, I get y is equal to positive 2/3 x minus 4. So as we saw before, we can identify the slope of this to be 2/3, and we can identify the b value to be minus 4. And so that means that we've got minus 1, 2, 3, 4. If I go ahead and plot, this would be my y-intercept at the ordered pair minus 4, 0. And then remember what we do next. We use the slope as a recipe to find another point on the line. So I'd like you to pause the video and try to do that on your own. Find another point on this line. We know that negative 4, 0 is on there. Excuse me, folks, I've mislabeled that. This should be 0, negative 4. We know that 0, negative 4 is on this line, and now use the slope as a recipe to find an additional point. So using that slope as a recipe to find an additional point, I'm going to remember that the slope is the ratio of rise over run. And so what I'm going to do is I'm going to rise 2 units, 1, 2, and then I'm going to run 3 units to the right, 1, 2, 3. And that gives me a second point on this line. Okay? Let me go ahead and put my tick marks, get caught up with those. We went to the right 3 units, so 1, 2, 3. And now I've got these 2 points on the line, and all I need to do is connect them. So here you can see I went ahead and plotted this the line passing through those 2 points, and we did so using the what? We did so using the slope-intercept form of the line. Okay. Let's do this very last one. This is the same line as it was in question number 5, but we're going to go ahead and again use the standard form. So how does the standard form work? Remember, when we're in this form, ax plus by equals c, it's easy to identify the x and y intercepts. We know that the x-coordinate of the x-intercept will just be c divided by a, and that the y-coordinate of the x-intercept will just be c divided by b. So when I go to find the x-intercept, as a reminder, what do? We let y equals 0, and then using this cover-up technique, for 2x minus 3 times 0 equals 12, by inspection we can find that x is equal to 6, so we know that the x-intercept is the ordered pair 6, 0. So I can go ahead and plot that x-intercept now. Let's go ahead and just do so. There's the ordered pair 6, 0. And now let's go ahead and find the y-intercept. So to find the y-intercept, we're going to go ahead and let x equals 0. And so if we solve for y, we'd have 2 times 0 minus 3y needs to equal 12. Using that cover-up technique, we find that y is equal to minus 4. So what have we found? We've just found that the y-intercept, careful, is the ordered pair 0, negative 4. Remember, intercepts need to be ordered pairs. So now I can go ahead and plot the y-intercept, which is the ordered pair 0, negative 4, right there. And now I'll draw the line passing through those 2 points. And there we have it. Folks, I want to point something out to you. First of all, notice that in all these cases when I drew the lines, I drew arrows on either end of them. And the other thing is I don't draw what I call wimpy lines when I'm graphing them. Meaning I've sometimes seen students, they go to graph a line and they graph it like this. Meaning I've got this massive XY axis here and they just draw some little line that looks like this. It's important to me that you extend your lines, if they are indeed lines, all the way through the given coordinate system. So don't just draw a short line like so, draw it all the way through the given coordinate system. Okay, folks, that finishes up my explanation of graphing lines. We will work some more with lines, and eventually you're going to have one of your skills tests over them. But in the meantime, I'm going to leave you to try 2 problems. Try number 7. There's a little bit of a hint here. I put this in italics and told you what to do if you got stuck. But I'd like you to try to graph this using the slope-intercept form that we were just discussing. Then what I'd like you to do is repeat this. You're going to go ahead and graph the same line. Folks, in your notes, this will be the same equation here. The minus 4/3 x minus 12. You'll graph this same line, but I want you to do it putting it into general form first and then graphing it. So the way you'll do number 8 here is very similar to the way I did number 4. All right, folks, that's all I've got for you. Thank you for your patience, and I'll see you either in class or in the next pre-work.